Okay, so this time let's go to the discussion in task 3, which is on naming of alkenes and alkynes. Okay, so we still have this table. We have IUPAC name, common condensed form, line structure, and then we have a complete structure. So in number 1, we are given with a complete structure. Okay, so the complete structure is like this. It is this one. Okay, so this is the structure. Now this time, first thing to do is we are going to find the longest chain. Okay, so let's count. Now also first thing also to take note that our double bonds will have the lowest number. Okay, so we have, if we count from here, example, we have 1, 2, 3, 4, 5, 6, 7, 8. Okay. Or we can count here to here. That's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, so the longest chain is this one. This one is the longest chain. And then for the double bond, we have 2 and 5. If we count from here, we will have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if we will count from left to right, then our double bonds will have 4 and 8. This will be 12 if we add that one. And if we count from right to left, that will our double bonds will be 2 and 4. It's 6. So we will choose the counting in the black one from right to left. Okay, so we will have, since this is an 8, so we will write oct. So oct. And then we have methyl. Okay, we have our substituents. This one is our substituent, and this one is our substituent too. So that will be 4, 5. So we have 4 and 5 dimethyl because it's 2. Dimethyl oct. And then we will write the double bond. So we have 2, 4 di in because it's an alkene. Okay, so this is the name of our alkene. 4,5 dimethyl and 4,5 dimethyl oct, 2,4 diene. Okay, so we have number 2 is we are going to write the condensed structure on it. Okay, let's write here na lang hapon. Okay, so if we are going to write the condensed structure, then that will be, since it's an octane, so we will have 1, 2, 3, 4, 5, 6, 7, 8. And then in carbon 4, we have 1, 2, 3, 4. We have methyl. And carbon 5, we have also methyl. And also in carbon 2, if I count from here, 1, 2, double bind. In carbon 4 also, it's double bind. 1, 2, 3, 4. Okay. Alright, so that's it. And then what we're going to do next is we distribute the H. So you have H here, H3, and then here the carbon here we will be left with 1 since there's already a double bond. But let's write it clearly. So we have H, and then we put double bond here, class. Take note of that. Then here we have H, another H here. Okay, sorry, we have another H. Only one H because ang kanina sinana pa siya double bond here. And then this C has no H anymore because it's already occupied. Then we have here one H. Then we have here H2. H2. Then we have H3. Okay, so this is our condensed structure. Now, if we are going to write it in a line structure, that will be, okay, for a line structure, that will be, I will use another pen, this one. So 8, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we have in carbon 4, we have methyl, carbon 4 and 5. 1, 2, 3, 4, 5. And we have 4 here. 1, 2, 3, 4, 5. And then in carbon 2, 1, 2. So here, carbon 2. Then we have 4. Also, carbon 4 has double bond here. Okay, so this is our condensed structure. Okay, so thank you. Now, 2 points for each. We have 2 points, 2 points, and then 2 points. Okay, so let's go to number 2. The given in number 2 is this one. It's a condensed structure. So if it's a condensed structure, okay, it is this one. Okay, first thing to do is you count. Okay, since this is a straight chain, no problem. We count from right to left or left to right, whichever we will arrive at the same result. So we have 1, 2, 3, and 4. Okay, so we have 4 for sure. This is but. Okay, and then let's go for the branches. Then there's no branches or substituents. Now let's go to the double bonds. Okay, for the double bond, we have this one. Okay, so we have one but one to die in because it's a double bond. It's an alkene to die in. So that's it. Nothing more, diba? Okay, so this is the name. It's but one to die in. Now, what about our line structure? For the line structure, okay, for our line structure, we just write 4. So we have 1, 2, 3, 4. 1, 2, 3, 4. And then in second carbon, oh, in first carbon we have double bond, and in second carbon two double bond. Okay, so that's it. But want to die in. Now, what about our complete structure? So we have 4. Okay, so I'll write 1, 2, 3, 4, and then we have double bond here, double bond here. Then we have here one bond. Okay, and then you distribute the H atoms. Okay, H, 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 then H, and then H, and then H, and then H, and then H. So here it is. This is our our but 1,2 diene. But 1,2 diene. Okay, now let's go to number three. For number three, we are given with this one. Oh, we are given with IUPAC name. Okay, so for IUPAC name, that is 4-methyl pent 1,3 diene. Okay, it's a pent, so it's 5. Now let's count. Okay, pent. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then we have, and now in carbon 4, we have methyl. So we have this one. And in carbon 1 and 3, we have double bonds. 1. Okay. So here it is. This is our 4-methyl pent 1,3-diene. Now let's go for the lines. That's for line structure. Now for the condensed structure, that will be, okay, I'll write this one. So pent 1, 2, 3, 4, 5. Okay, in 1, 3 we have diene. Okay, we have double bond because of in. Then 1, 2, 3. Okay, 1, 2. And then we have in carbon 4 we have uh CH3. Okay, then let's have this one CH2. This one is CH. This one here is H only. Okay, I'll write this one clearly. Then we have H here. And then we have H3. Okay, so that is our condensed structure of 4-methyl pent 1,3-diene. Now let's go for the complete structure. Okay, for complete structure, let's write that one. So we have 1, 2, 3, 4, 5. Double bond here. And in number carbon 3 also double bond here. And then we have in carbon 4 we have CH3. C here. CH3 methyl. Then this time, okay, distribute H. Okay, of course. This is a bond. Okay, then we have our H. H. Sorry. We have our H. 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 We have our H. 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 Okay, so this is our 4-methyl pent 1,3-diene. Okay, check your answers. Now we have, okay, we are in number 4 finally. Okay, in number 4 we are given with this one, and that is this one. Okay, we have double bond here. Let's put that. Okay, let's put. Now, okay, so first thing to do is you count a straight chain. So we have 1, 2, 3, 4, 5, 6, 7. So this will be a what? This will be our hex. Hex. Okay, this one is a hex. have hex. Okay. Now notice class. Okay. When in counting, first is you give priority to the double bonds, triple bond. First thing, Jud, is the triple bond. You give priority on that. And the second is the double bond. Then last is the substituents. Okay, but here there's no triple bond. So the priority here is double bond, and then the substituent. So the priority will be 1, 2, 3, 4, 5, 6, 7. So this will be our counting for us to give the smallest number in our double bonds. Or what if we count from here? 1, 2, 3, 4, 5, 6, 7. So let's add that to one class. So for our that will be our 2 methyl. We will have also 5 in, and we will have also 3. Oh no, we have 3 here. 3 in, and we have 5 in. Then for the block 1, we will have, if we count from left to right, we will have 2 in, 4 in, and then we have 6. 6 meth. 6 methyl. Alright, this will be 12. And this will be 10. Okay, so ang atong sundan class is number is this, number 3, no? Okay, so class, we forgot because we have an ISO. Okay, so let's not follow this one, class, because as you can see here, class, there's a Y. That's an ISO. Okay, so if this is an ISO, then we count from here 1, 2, 3, 4, 5. Okay, so this one is not a hex, but it's a pent. So we have pent, and then we have ISO pent. Not to. We'll have ISO pent. Now for the double bond, we have, this is carbon 1. Carbon 1 naman ni siya. 1, 2, 3, 4, 5. So 1, 2, 3. So we have carpent 1, 3 in. Okay, so this is our IUPAC name. No, we will not look at this. We have that one. Isopent 1, 3 in. And also what about the double or the condensed structure? So we will have 1, 2, 3, 4, 5. And then we have 5. Then Okay, so in carbon 2 we have 1, 2. In carbon here also 1, 2, 3, 4. Double bond also. And then we have here. Okay, we have here. Okay, we have here PASI. And then we have another one. CH3, CH. Sorry. We have here CH3. This one is CH3. And this one is H. Okay, this one is CH3. This one is H Nisha. Okay, we have H, double bond, H. Then we have here also an H. Okay. And then we have here an H also. Okay. 1, 2, 3, 4. Yes. And then we have this one. Okay, so this will be our condensed structure. Okay, now what about our no complete structure? Simple. So 1, 2, 3, 4, 5. And then in carbon 5 we have C again. We have C here. Then we have CH. We have H, H, H. Then here, uh, we will have H. Oh, sorry class, this one. Wala na ni siya class, not an H3. Daghan na kayo bonds. That's CH only. And then we have here, we have double bond here. We have okay, double bond here also. Okay, then we have sobra ko lang og saka H. Okay. So we have this one. 1, 2, double bind, and then 1, 1, 2. Here, double bind here. Okay, so let's have a binding. Okay. Alright, then this one. Only one. Here, only one. Okay, then we will distribute the H here, the H, 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 and then H. So this one is our complete structure. Okay, that's our complete structure for our isopent 1,3 diene. Okay, so let's go to number 5, I think. Okay, it's number 5. So number 5, we are given with this one. It's an IUPAC name. The name is 2,5-dimethylhex-3-ine. Okay, so there's an ine. So we can assume, we know that this is an alkyne. So expected that it has 3 because of this ine. It has 3 bonds, so it has triple bond. Okay, then it's hex. So we have, let's draw the line structure. So we have 1, 2, 3, 4 again. So that is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 only here. 1, 2, 3, 4, 5, 6, 7. That's hex. And then it says that in 2, 5, it's 1, 2. There's a methyl here. Methyl. And also in carbon 5, it has a methyl too. 1, 2, 3, 4, 5. Then we have ine. In carbon 3, we have an ine. We have triple bond. Okay. So that's it. This is our line structure. And if we are asked, okay, for the condensed structure, this will become 1, 2, 3, 4, 5, 6, 7. Okay, so we have here CH3, then CH2. Okay, because in carbon 1, 2, we have methyl here. And in carbon 3, we have triple bond. And then in carbon 4, 5, we have a methyl. Okay, so for our condensed structure, this is it. This one is H, and this one is an H. This one has 2, H2, 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 CH3. Okay, so that's it for carbon. Okay, for number 5. Okay, so no H na ni siya, class. This one has no H. So we have double bond. Okay. Then 1, 2, 3. Only H here. Sorry, we have AC. C. We have H and C. Then we have, okay, 1, 2, 3, 4, 5, 6, 7 lagi ni. So we have 3 ra. Okay, so we have 3. Okay, so this is it. Then what about the complete structure? So we will have, okay, so 1, 2, 3, 4, 5, 6. We have in carbon 3, we have 1, 2, we have methyl, we have double bond, and we have 4, and then 5, we have methyl again. Okay, so C. And we have C. This time, let's distribute the H. Okay. As you can see. Okay. So, this is it. This is our complete structure. Complete structure. Then you have also here H, and we have H. Okay, so this is our complete structure for number 5. Okay, now this time let's go to number 6. Okay, so number 6 is we are given with this one. Okay, we are given with this one. Now, we know, class, that here there is a carbon. Carbon pud na siya dira. Kay dira man na-form ang triple bond. Dira man siya, na siya carbon. Dira, di siya kay straight ra na siya. So, if di na ko ni siya straight, ano na siya? 1, 2, carbon 3, 3, Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Ano na siya class? And then we have a triple bond in 1, 2, 3. In carbon 3. 1, 2, 3. Okay, here. And then we have here. Then we have here. So, kani siya is equal to this red one. Equaler na sila class. Okay, so let's count since it has 5. So this will be a pent. Okay, and pa siya diri oh. This will be a pent. Okay, so we will write pent, pent. Okay, so we have pent. Okay, and then class, we again I've talked na dito ta mag-una sa to our priority is our triple bond. So dito ta mag-count na mahatagan na to kaning lowest ang ato ang triple bond at the same time ato double bond. But here it says that our triple bond, so we will count from here 1, 2, 3, 4, 5. Okay, so we have in carbon. Okay, we have here. So 1, it's an 1 in, and then we have 2 ein. Follow class. We have the double bond. We have in because E comes from Y. So una itong in. And then we have 2 ein. And then what about the methyl substituents? We will write that one. We have 2,4-dimethyl. Okay, so we will write that one. We have okay, 2,4-dimethyl. Pent 1 into ein. Okay, so that will be the name, which is 2,4-dimethyl pent 1 into dash ein. Okay, so this is our name. Now also class, we are asked of our complete structure, our condensed structure first. So condensed structure will be 1, 2, 3, 4, 5. And then in carbon 1, we have double bond. In carbon 2, we have triple bond. Okay. And then we have in carbon 2 also we have 1, 2. Okay. Klase, sobraan na kayo itong carbon ay. Sobraan na kayo og double bonds. Og mga bonds. Carbon can only accommodate 4. It can accommodate 4 bonds only, but magbutang po siya tadi methyl. Then sa 4 na po. Okay, okay rin ni diri. But here, the carbon here, 1, you see this one? The carbon here will have how many bonds? Kani nga carbon? 1, 2, 3, 4, 5, 6. Oh my goodness. Okay, it will have 6. Sure, it should do 4. One, two, three, 4, 5, 6. Oh God, there are 6. 1, 2, 3, 4, 5. It's 6. Dili siya. Wrong ni siya ako ang simplification. Napag-simplified. Oh, you see this one class. Let's count ha. We have carbon 1, carbon 2, carbon 3 po ni diri, carbon 4 pagkatapos, carbon 5 na po ni diri, and then carbon 6. It's not pent. It's not pent. Okay. So let's do this again. Okay, so we have again, so the structure there is this one, and then we have, okay, that one, and then we have 1, 2. Okay, so if we have that one, let's count 1, carbon 2, carbon 3, kay for sure class, diri mo na class, oh. Napo na siya carbon. Dira kay mag-connect mo na siya. Diri mo na sa duha. So, carbon 3, carbon 4, and then this one, this will be carbon 5 and carbon 6. Okay. Kung na siya kwaon ha. Okay, so we have carbon 6. Now, this is our hex. Okay, this is a hex. So, we will write that one. We have hex. Okay, we have carbon 1. Hex 1. That is an in. Then 1, 2, 3. Our number 3 is our ine. Carbon 3 is ine. And then for our, for our substituents, we will have carbon 2. Carbon 2. And we have carbon 5. Carbon 5. They are methyl. So we write dimethyl hex 1 in 3 ine. Okay, so this is our, no, it's this one, 2, 5 dimethyl hex 1 in 3 ine. Okay, so padakuan ako class ha, so you will see it. Okay, now for our condensed structure, we will write, there are 6 nodes. We'll write 1, 2, 3, 4, 5, 6. Okay, in carbon 1, we have double bond. And then in carbon 3, we have triple bond. So 1, 2, 3, 1, 2, 3. And then in carbon 2, we have double methyl. And in carbon 5, we have methyl again. Okay, so then we will have the distribution. So this one an H2 na lang iyang makuha ani nga carbon. And then this carbon, wala na siya H. Then also, this carbon has no H na pod. And this carbon has 1, 2, 3 has an H. Then this has an H3. Okay, so this is our, ni siya. Class, duol ba ni sila ha? Duol. This is our condensed structure. Okay, then what if we write the complete structure? For our complete structure, that will be, follow lang taan ni gamay. Okay, so we will have this one. Okay, we have 1, 2, 3, 4, 5, 6. So we have here double bond here, and then we have triple bond, and then we have methyl, and then we have, and now here methyl again, then double, then single bond, single bond. Okay, this one has C also. Then then let's distribute each. Okay. Then wala ni siya, and then we have this one. Okay. Then let's write the H. Let's distribute. So we have H, 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 H. And then this one too has an H. H, H, H. Then H, 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 H. Okay, you see this one class? This is our complete structure. Okay, now let's go to number 7. Finally, we are in number 7. We are given with this one, an IUPAC name. Okay, the IUPAC name is this one. A condensed structure, rather, CH3, CH, CH, CH. Okay, so let's count. Now, class, we have, okay, so asa ta magsugod? Dire or dire? We will, sa right to left for us to give the lowest uh, number for our alkyne because our top priority is our alkyne, then alkene, and then the least is alkane. Okay, so we will have count. So we count 1, 2, 3, 4, 5, 6, 7. Okay, so this one is a hept, and then we have two. We have one. Eh? We have one ein. We have one ein, and then we have five. Oh, okay, class. Unahon na to atong in because in writing it's alphabetical. Ang ato pag number una ang triple bond ito priority but during writing we will uh follow alphabetical order. So we have 5 in, we have 1 ein. Okay. So that is hept 5 1 in, hept 5 in 1 ein. So that is our no. This is our IUPAC name for this Then for our line structure, so we have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Okay, and then we have triple bond 1, 2, and then in the fifth carbon 1, 2, 3, 4, 5. Double bond. Okay, so this is our line structure. For our complete structure, that will be this one. So we have 1, 7 kabuk, 2, 3, 4, 5, 6, 7. Carbon 1, we have 3. 1, 2, 3. Okay. 1, 2, 3, 4, 5. Double bond here. And then that's it. Single bond na yun. Okay, then distribute each. H, 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 H. Okay, so this is our our complete structure for number 7. Okay, so we have this one. Okay, so please check your paper, check your works, and that's all for this discussion. Thank you so much. See you on next discussions. Okay, goodbye.